Good morning. Today we are going to discuss the series and parallel circuit analysis. So the learning objective of today's lecture is, first, we will be able to understand the concept of equivalent circuit. What is equivalent circuit and why we need equivalent circuit? Second, you will be capable of combining resistors in series and parallel to obtain the equivalent circuit. And third, you will be able to carry out circuit analysis based on equivalent circuit. Before we officially start, let's briefly review the prior knowledge that we discussed in previous lectures. The first one is Ohm's law. So Ohm's law states the relationship of voltage and current over a resistor. So if the resistance is R and the voltage is V and the current through the resistor is I, we have V equals I times R. So this is Ohm's law. The second one is the Kirchhoff current law. So this states that the sum of current entering the node equals the sum of current leaving the node. So in this example, we have current I1, I3, and I4 entering the node, and we have I2 and I5 leaving the node. So we can obtain this equation: I1 plus I3 plus I4 equals I2 plus I5. This is KCL. The next one is Kirchhoff's voltage law, KVL. It states that the algebraic sum of all voltages around a closed loop is 0. So in this example, we have V2 plus V3 minus V4 plus V5 minus V1 equals 0. Because when we move from positive to negative, we add VA, and move from negative to positive, we subtract VA. This is KCL. So this is the prior knowledge we may need for today's lecture. So we answer these two questions first. What is equivalent circuit and why we need equivalent circuit? So here I give you two circuits and ask you to choose the circuit you like and calculate the current from the voltage source. Which one would you like to choose from the two circuits, A or B? Tell me your answer. So I noticed most students choose B. Why choose B? Yes, B is simpler. You can directly use Ohm's law to calculate the current, right? So that the current equals the voltage, which is 5 volts, over the resistance 270 ohm. But I will tell you that these two circuits, they are equivalent. So these three the circuit A has 3 resistors. These 3 resistors, we can get an equivalent circuit, which is only 1 resistor, and its resistance is 270. So we answer this question, the second question, why we need equivalent circuit. Because the equivalent circuit can simplify more complex circuit and make the calculation easier. That's why we need equivalent circuit. Now let's go to the official definition of equivalent circuit. So equivalent circuits are used to simplify complex circuits and aid in circuit analysis. So here we have example. We have the original circuit. It has 5 elements, A, B, C, D, E, F. And the equivalent circuit only has 1 element. It's obvious that the equivalent circuit, the calculation is much easier, right? So the equivalent circuit is a theoretical circuit that retains all of the electrical characteristics, which includes voltage and current of a given circuit. So in the original circuit, we have 5 elements, and we have the voltage V1, I1, and I2. We can use one element to replace these 5 elements. So we use F. So one element, and also keep the or retain the electrical characteristics so that I1, I2, this does not change. So the I1, I2, and V1 in the equivalent circuit equals the I1, I2, and V1 in the original circuit. So these two circuits are equivalent. So this is the definition of equivalent circuit. How can we get, so the next question is, how can we get the next question is, if the resistance of A, B, C, D, E, F are given, how can we calculate the resistance of F so that these two circuits are equivalent? Let's take a look at the equivalent circuit for series circuit first. So in series circuit, all the components are connected end to end to form a single path for the current. So in series circuit, the current is the same. So here is an example. I want you to use your intuition and just guess the equivalent resistance of two 100 ohm resistors in series. Choose A, B, or C. Here I use the word guess because I don't want to give you any pressure. Just guess which one you like, which option you like. So so many of you choose A, right? And some of you may choose B or C. Let's do the interactive lecture demonstration. So here I have two resistors. I connect the two resistors in series, and I have the multimeter which can measure the resistance. I need a volunteer to help me obtain the resistance of the two resistors in series. So what value did you get? So yes, you get 0.2K, which is 200 ohms. So by the observation, it looks like the equivalent resistance of series circuit equals the addition of individual resistance, right? So by observation, you can obtain that. So this is the original circuit. The equivalent circuit will use one resistor, and the resistance equals R1 plus R2 by observation. So can you derive the equation for the equivalent resistance of series circuit using prior knowledge, so which is Ohm's law and KVL? So we obtained the relationship by observation, but we also want to verify this relationship using mathematical derivation to derive this equation using the prior knowledge. So let's take a look how to derive this relationship. So because the circuits are equivalent, so the equivalent circuit retain the electrical characteristics so that the current from the voltage source is the same for both circuits. I use I to denote the current from the voltage source. So for the first circuit, this voltage equals the voltage on R1 plus the voltage on R2. So that is I times R1 plus I times R2. For the second circuit, the voltage equals, because there is only one resistor, so that it equals I times R. And these voltages are equal, so that I times R1 plus I times R2 equals I times R. So we can eliminate I on both sides of the equation, so we can obtain R equals R1 plus R2. So you use KVL and Ohm's law to obtain this relationship, right? So the next And here we did, so here we only have two resistors, and this relationship can be extended to include multiple resistors. So if we have n resistors, the equivalent in series, the equivalent resistance equals the summation of all individual resistance. The next, so we finish the series circuit. Next, we will introduce the equivalent resistance for parallel circuit. So we have the original circuit R1 and R2 are in parallel, and we use one resistor as the equivalent in the equivalent circuit. So here, use your intuition and guess the equivalent resistance of one 100 ohm resistor in parallel with a 1000 ohm resistor. I didn't expect you to obtain the exact value of the equivalent resistance. Just guess the range of the equivalent resistance. It is smaller than 100, equal 100, between 100 to 1000, equal 1000, or larger than 1000. Just guess the range of the equivalent resistance. So some of you choose A, some of you choose E, right? Let's take a look at the interactive lecture demonstration. So I need another volunteer to help me connect the circuit and measure the equivalent resistance. So you can see from the multimeter, the equivalent resistance is 91.1. So it is, we choose A, so that the equivalent resistance is smaller than the smallest resistance in the original circuit, right? So by observation, we can obtain this conclusion. The equivalent resistance is smaller than the smallest parallel resistor in the parallel circuit. But by observation, it is hard for us to obtain the equation to calculate the exact value of the equivalent resistance. So we need to obtain this relationship by mathematical derivation using the prior knowledge. So the prior knowledge is Ohm's law and Kirchhoff's current law. I want you to derive the equation for the equivalent resistance of parallel circuit using the prior knowledge. So let's take a look on how to obtain this relationship. So here, because these two circuits are equivalent, so the current from the voltage source is the same. So for the first circuit, this current I equals I1 plus I2, right? So I1 equals the V over R1. I2 equals V over R2. So this is I for the first circuit. How about the I in the second circuit? I equals V over R. So that I is the same. So we can obtain that these two equations, they are the same. So we can obtain 1 over R equals I over R1 plus I1 over R2. So this is the equation for equivalent resistance calculation in parallel circuit. And obviously, there were two resistors. This equation can be extended to include multiple resistors. So we have this equation. And we also define the conductance as the reciprocal of resistance. So if we use the conductance so that the total conductance, or the equivalent conductance of parallel circuit equals the summation of the conductance of each individual resistor. So this is the parallel circuit. Now let's go back to the circuit. Can you calculate the exact value of the equivalent resistance of the previous circuit? So we have R1 and R2 in parallel. Can you calculate the value of the equivalent resistance? So here I will give you student two more minutes to do the calculation. And okay, so did everyone get, what value did you get for the equivalent resistance? Did everyone get 91.1? So now we can apply what we learned in today's lecture to solve circuit problems, right? So do you remember why we need a circuit? Why we need equivalent circuit? Because it can simplify more complex circuit and aid circuit analysis. So the goal is to aid circuit analysis. One of the learning objectives is that you will be able to carry out circuit analysis using the equivalent circuit, right? So in this example, you were asked to find the current I and IO in the circuit. So I would like to give you 1 minute to think individually, 2 minutes to pair with your neighbors and have discussions. And finally, I would like to invite one volunteer to share your thoughts. So from this example, we can see that without the equivalent circuit, it is hard to calculate the value for current I. But with the help of the equivalent circuit, we simplify this circuit and we can easily obtain the value for the current I. And once we obtain this I, we go back to the original circuit and then carry out the circuit analysis for other current or voltage values. So here we summarize the steps of how to solve circuit problems using equivalent circuit. So first, we systematically reduce the resistive network so that the resistance is seen by the source is represented by a single resistor. Next, we determine the source current for voltage source, because here is the voltage source. If it's a current source, we determine the source voltage, and then we expand the network, retracing the simplification steps. Apply Ohm's law, KVL, KCL, voltage division, and current division to determine all currents and voltages in the network. So that's how we solve the circuit problem using equivalent circuit. And we also have examples from the FE exam. So in the previous discussion, the value of the individual resistance is given in the original circuit and ask you to calculate the equivalent resistance. In this example, the equivalent resistance is given, and some individual resistance are also given, and ask you to calculate the resistance of one resistor. So now let's summarize what we discussed today. We discussed the equivalent circuit, and then we introduced the equation to calculate the equivalent resistance for series and parallel connection. So next, let's go back to the learning objective to see now let's go back to the learning objective to see if we meet the learning objective. So under the first, understand the concept of equivalent circuit. So two questions: why we need equivalent circuit, simplify the complex circuit, and aid circuit analysis. What is equivalent circuit? So we understand the concept of equivalent circuit. The next one is capable of combining resistors in series and parallel to obtain the equivalent circuit. So in this example, you are able to combine the resistors in parallel and series to obtain the equivalent circuit. Finally, capable of carrying out circuit analysis based on the equivalent circuit. So based on the equivalent circuit, you can carry out the circuit calculation. So we finished this lecture. So we conclude this lecture and with the and meet the and so we finish. So now we can finish. So that's the end of the lecture, and I believe we meet the learning objective. Thanks. Next one is the assignment. So assignment is to help you better familiarize the circuit analysis. So the homework will help you be more familiar with what we discussed today, and any questions and answers. So any questions? That's end of the lecture.